Hey guys, so today y'all are learning asynchronously. So let's get into today's lesson. Um, it is just going to be notes, and then there will be a short Delta Math activity afterwards. So make sure you submit that. Okay, getting into the notes. So if you remember, this chapter or this unit was called Basic Vocabulary and Transformations. So we did our basic vocabulary. Now we just have the transformations. So in transformations, we have a couple more vocab words, but they're not like important enough that we need to have the entire or there aren't enough of them that we need to have that whole organizer that we had for the other ones. So the first vocab word we need to know here is the pre-image. So the pre-image is the original figure, and you'll see what we mean in just a second. So all you need to know for now, pre-image is the original figure. Then we have the image, which is the new figure after a transformation has occurred. And a transformation is a way of mapping, and we use the word mapping to define a transformation. So if we say something transformed, we say it mapped onto something. So it is a way of mapping the pre-image onto the image. There are three types of transformations discussed in this unit. The first type of transformation that we're going to be learning about is translation. And a translation is just going to be like a shift from like left to right, up and down, or diagonally. It's just moving something. And then we have the second one we're going to be learning is I forget what order it goes in, but I think the next one is reflection. So there's translation and reflection. Reflection is just like it sounds. It's like flipping something over a line or over something else. And the third one we're going to be learning is a rotation. I forget what order we learn rotation and reflection in. But I know translation is the first one because that's the one we're doing today. Okay, so we have translation, reflection, and rotation. And then we have these images here. We have, it asks us to identify the type of transformation occurring. So, well, this one, this B, so obviously we have this B and it is reflected over like an invisible line right there, and then you can see that it forms the image opposite that. So that was a reflection. The next one, we have this C, and I'm skipping the A for a reason. We have C, and this C down here moves up to this C up here, or maybe it's the other way around. Maybe this C up here goes to that C down there. But either way, it is just shifting. It's not turning at all. It's not reflecting at all. It's just shifting. So this one is a translation. And then the A, I said that I skipped it for a reason because, well, the last one that we haven't used is rotation, and obviously it looks like this A is being rotated. But I would argue that there's another one we could also say it is, because translation doesn't involve any turning it at all, but reflection can look like it has been turned. So imagine that there's like an invisible line, like maybe not there, but like there-ish. And I took that A and I reflected it across that invisible line, and now I have this new A. So I took this A, and this A would be the pre-image, and then I reflected it across the line, and now I have this new A, which would be the image. So even though this one is supposed to represent rotation, I would also argue it could be reflection. And the only reason that works is because A is a very symmetrical shape. If it was B, you would be able to see that it had actually rotated instead of being reflected, because see, when we reflect a B, it looks backwards. When you reflect an A, it still looks like an A. So I would say this one is rotation / reflection. I'm sorry about my handwriting. It's not great right now. Okay, so we had rotation, reflection, and translation, the three types of transformations we're going to be learning about in this unit. We will be learning about more later in the year, but these are the first three that we're worried about. And the three things, or the reason that we learn about these three first is because they have something in common. They are known as isometric transformations. And isometry, spelled right here, I-S-O-M-E-T-R-Y, is a transformation in which the pre-image and the image are congruent. And we learned about congruency last week. So congruent just means that they're going to have the same like angles, same sides. They're still going to measure the same. So looking at these examples here, we have this arrow is mapped onto this arrow, or maybe it's the other way around. And it looks like it was just a translation. It looks like it just shifted up. And I would say that those are the same size. It's the same shape. So this is isometric. With B, we have like this, I guess it's like a walking hot dog or something. I have no clue. But this one, it gets like, well, it goes from this small one to this large one. Or maybe it goes from the large one to the small one. I don't know. But either way, it does keep all the same shapes, but it does not keep all the same measurements. So if I measured this large one, it would be larger than the small one. Therefore, it is not congruent. So this is not an isometric transformation. So not isometric. And that is actually a transformation called a dilation, which we will learn about later in the year. And the final one, this music note. So obviously it looks like it's just been reflected because it flipped across an invisible line here. Actually, you know what? Yeah. So I was going to say that even though the music note itself has been reflected, if you look at the shadows like have two, but you can see this shadow is like sticking out on the right side, and this one is sticking out on the right side, meaning that it doesn't really make sense. So But anyways, I assume we're just talking about this music note itself, not its shadow. So it got reflected, but it still preserved the same shape, still preserved the same size, still keeps the same angles. Therefore, reflection is isometric. If we ignore the shadows, of course. All right. So, yeah, this is our first page of notes about transformations. Oh, by the way, if you have not been able to find this, it is in the Week 2 folder on Schoology under Thursday, 9/10, and it's called, I believe, Week 2 Notes. Okay. And on to the next page, let me just look. So yeah, okay, reflection comes before rotation. Okay. So, on to the next page. Actually, yeah, on to the next page, we have this isometric transformation here. So this is an isometric transformation. We have, I'll highlight it. What is it? Okay. We have figure, oh, that is not big enough. Maybe like that. Yeah, okay. We have figure ABC, which is this triangle here with the A, the B, and the C, is being mapped onto figure DEF. And they tell us there that it reads as maps onto, which is what we say when we see that arrow. So we don't say figure ABC points at or whatever. It's figure ABC, and then the arrow, you would say maps onto figure DEF. So you can see the points A goes to D, B goes to E, and C goes to F. And this is important when we map figures like this, because the first point you mentioned in the figure is A, and we said A mapped onto D, which is why D is the first one mentioned here. And then we said B mapped onto E, which is why E is the second one, and C is the third one, or C and F are the third one. So they have to be in order. I can't say figure ABC maps onto figure FDE. That doesn't make sense, because that would imply that A mapped onto point F. When it didn't, it mapped onto point D, because all it did was shift. Okay. So another thing we might see is figures like this. So here we have a reflection. It's being reflected across the y-axis. And you can see that we have G mapping onto this G with the little 1, it looks like. It's not a 1. It's a little like apostrophe almost, but the way you read that is G prime. So if you see like a little 1 as an exponent, basically, it means prime. So that's G prime, and H onto H prime, and K onto K prime, and J onto J prime. And we can see that it reflected here. So just the letter indicates the pre-image. And the letter with the prime, or the ones with the prime letters, indicates the image. Remember, the pre-image is before translating it or transforming it, and the image is after transforming it. That's how I knew when I was looking at this that the arrows were going from right to left instead of from left to right, because I know, because I studied math, that the G should go onto G prime, the H should go onto H prime, instead of the H prime going to H and the G prime going to G. Okay. What else do we have? Oh, and I didn't even see this part down here. So this type of transformation, we said it was a translation. And the name of the pre-image, well, the pre-image was the one that got mapped onto the image. So that meant we went from A to D, and B to E, and C to F. So the pre-image was this triangle ABC, and they call it figure ABC. But in geometry, we learned about like how to name an angle. Like if you have an angle, you put the little angle symbol in front of it. If we're talking about a triangle, we put a triangle in front of it, and we say triangle A, B, C. And that is telling me that is ABC, and it's a triangle. So the pre-image was the one that was before it had the translation occur. The image is after it has the translation occur. So the image here is going to be triangle D, E, F. And then it has the B mapping onto blank. And as we said, the B mapped onto E. Okay, cool. Now with this one, the type of transformation, we said it was a reflection because it's being reflected over the y-axis. The name of the pre-image, so before it got translated or reflected. So here, they don't tell us the name of it. So the way we would read it is just, you would usually just pick the first letter alphabetically. So in this case, it is G. So G is the first letter alphabetically out of G, H, J, and K. And then you just go clockwise. So I start at the G, and then I go around this way. So I wouldn't be able to read this G, H, K, J, because the H and the K, or the way I just said it, I had H and K next to each other, but the H and the K aren't actually next to each other. So the name of the pre-image here is going to be G, H, J, K, because G touches H touches J, and J touches K. I can't go from G to J or from H to K. And with these four-sided figures, these quadrilaterals, we typically would not put anything in front of them. We would just say G, H, J, K. And if you see four capital letters, you know that it's most likely a quadrilateral of some sort. Actually, I have my computer sitting in front of me. Let me just Google that and make sure. So, naming a quadrilateral. Okay, yeah. So the results I'm seeing are all saying that, yeah, you just read the 4 sides clockwise. So exactly what I did. And even though I just said that we read them clockwise, and we start with the first one alphabetically, the name of the image after it gets mapped, after it gets reflected, is going to be, well, it's going to start with the G prime, because that's the first one alphabetically. And even though I said we would go clockwise, which means that K prime should come next, we don't want to do that because this is not just a any old figure, it's a image. It's something that got mapped. So the G went to G prime, and the H goes to H prime, the J went to J prime, and the K went to K prime. So you have to read them in the order of which they got mapped. So as we just said, G was mapped onto G prime. And J prime, so even though J prime isn't being mapped, it says J prime is mapped onto, and the way we would read this, or the way we would think about this, is like if I were to undo the transformation. So if I undo it, J prime gets mapped onto J. So J prime came from J. All right, continuing on, I'll just think about how much I want to get through today. Hold on. So here it has a definition of a translation. And I'm not really sure what I'm supposed to put here, so I'm literally Googling it. So like I said, I think in the last video, all the math teachers really just share our resources. So one of the other math teachers made this, and I'm not sure what they originally intended to have in that blank there. So hold on. Sorry about this. Okay, so a translation, we can basically think of it as sliding. Take a shape and you basically just slide it. So you are moving a shape without rotating or flipping it. And then we have this next vocab word here, vector. So a vector is going to be Well, a vector, I'm trying to think about how to describe this. Okay, so it's basically, it just describes a transformation or a translation. So a vector describes the translation. So a vector is going to tell me like how much up and over to shift it, basically. So there are two ways we can write the rule for a translation. So we can have this component form, which is the capital T, and then in the subscript there, we have the little, what are those, I guess, brackets of some sort. And then it has the H and the V, where H is the horizontal component, like left and right, and V is the vertical component, up and down. And sometimes the T is removed, and you'll just see like HV. So yeah, I don't like component form. I very much prefer coordinate form, which is the next one. And so since I prefer coordinate form, and I'm your teacher, you will most likely be seeing the coordinate form a little bit more often in this class. So if you see this T, and then it has the 3, -6, that means you shifted 3 to the right and down 6. Because the 3 is the horizontal. So that means since it's positive, it's going right. And the 6, or the -6, is the vertical. So that is going down 6. If you see a negative horizontal, that means you're going left. If you see a positive horizontal, you're going right. Negative vertical means you go down. Positive vertical means you go up. So if you see this T 3, -6, that's the exact same thing as x plus 3, y plus 6. And the reason I like this form a lot, or this thing here, but the reason I like this form a lot better is because it's kind of just like a formula. So if we're given a point, let's say the point is like 1, 1, all I have to do is plug 1 into the x, plug 1 into the y, because those are my x and my y value, solve, and it tells me my new coordinate. So that's why I like coordinate form a lot better. So apply the following translation rule to translate the point or figure. So I have this T, and the reason it's a T is because it's a translation. So I have T -5, 4, which is the same thing as, if I write it in coordinate form, so that means I have x minus 5. It's always x first because you read a coordinate as x, y, and I get the -5 from there. And then y plus 4. And it's that simple. So we have this point here, and this point is -3, -3. So I'll label that -3, -3. And we want to calculate what p prime is. So I'm going to take it and plug it into coordinate form. So let's see, I have -3, what did the coordinate form tell me? -3 minus 5, and then -3 plus 4. Because I just plugged it in the coordinate form. And when I solve that, -3 minus 5 is -8. And -3 plus 4 is 1. So the new location of the point after it's been transformed is -8, 1. And that's where P prime would be. And unfortunately, it's not on this coordinate plane at all. So I don't know why they made it that, but they did. Okay. So basically, the x goes to the left 5 because it's -5. So it's going to be going this way. And the y goes up 4, which is going to be like that. And we talked about a vector earlier. A vector is going to be represented as an actual line. So the vector, I'll draw it in, even though this graph isn't really accurate. I'll draw it in this purple, this lavender. So the vector is going to be basically the point that it ends up at. And it's going to be like that, what direction-ish. Not really positive because, you know, they didn't include as many points as they should have on here. But the vector is going to be going that way. And that's basically just saying it's traveling in this direction. So the vector just tells me what direction it's going, and the vector describes the translation. So it's describing it by saying, hey, we're going this way. The translation is taking me this way, so I'm going that way. Maybe this one will work. Oh, it does. Okay, this one works nicely. Okay. So on this one, we have to fill in the blanks here, but they give us that the coordinate form is x plus 1, y minus 3. So since it was x plus 1, I put a 1 there, and then a -3 there, because it was y minus 3. So I want to figure out where my points map to. So with the A starts at, what is this point? This is -2, 4. And if I plug it in, so I'll come over here. So let's see. It was, the x was +1, and the y was -3. So when I figure this out, I have -2 plus 1 is going to be -1. 4 minus 3 is 1, meaning the new location of A prime is at -1, 1. So at -1, 1, I will put a point, and I'm going to label it A prime. Next we have B, and B is at 2, 4. So I'm going to do the same thing again. So I have 2, and I'm adding 1, because that was what the translation described. And then I have 4, and I'm subtracting 3, because it was x plus 1, y minus 3. And 2 plus 1 is 3. 4 minus 3 is 1. Therefore, the location of B prime is 3, 1. So at 3, 1, I have a point. Hold on. So yeah, 3, 1 right there. And I will label it B prime. And finally, I have C, and I probably should have labeled that coordinate, huh? So that was 2, 4. And C is at 1, 2. So I will plug this one in. So it is x plus 1, and my x is 1. So I have 1 plus 1. And y minus 3. My y is 2. So I have 2 minus 3. Let's see, 1 plus 1 is 2. And 2 minus 3 is negative 1. Meaning that the new coordinate is 2, negative 1. And if I plot that, so 2, negative 1 is like right there. And this is C prime. And now I just want to connect these points. And you can see that all we did was take the same triangle and shift it right 1 and down 3, which was told to me by this translation thing here. So it told me that I was going, I can't draw arrows apparently. So right and down. So I went right 1, down 3, and we can see that the original triangle, the pre-image, was mapped onto the image, which was right 1 and down 3. And yeah, we just have this one more. Okay, so this one, state the translation rule in both component and coordinate forms. So I have these two triangles. This one looks like the original triangle because it's labeled A, B, and C. And this one is the new triangle, the image, because it's A prime, B prime, and C prime. So what I'm going to do is I'm just going to pick one of these points. It does not matter which one. I'm going to go with A because it's A. It's the first point alphabetically. So I have my first A is negative 9, 9, and that is mapped onto 5, 0. So we just need to figure out what happened between these 2 points. So between negative 9 and 5, to figure out what the mapping that occurred was, I need to take my y2 minus my y1, or not my y2 minus y1, sorry, x2 minus x1, x2 minus x1. And this is my x2, my y2, my y1, my x1, so I take my x2 minus my x1, which is going to be 5 minus negative 9. And 5 minus negative 9 is positive 14. And then I have my y2 minus my y1. And I should probably be calling this like y and y prime, but whatever, we'll call it y2 and y1 for now. We might get into more technical terms later. Okay, so then the y2 here is 0, the y1 is 9, so 0 minus 9, and 0 minus 9 is negative 9, meaning that the mapping was the x's went to the right 14, and the y's went down 9. So, right 14 and down 9. 14, negative 9. Or the x's went right 14 and the y's went down 9. And if I plug in a different point just to check it, which, let's see, I have negative 10, 5 to 4, negative 4. Negative 10 plus 14 is positive 4. and 5 minus 9 is negative 4, which is how we got from b to b prime. So there we go. That holds up, and it looks like we are correct. The mapping was 4, negative 9. Okay, so we will get into reflection on Friday, but for now, this is all we really need to know, and I will leave a Delta Math activity for you guys to complete. So please log into Delta Math. If you have not created a Delta Math account yet, or if you have not joined my class in Delta Math yet, my teacher code is 872874. So please do so. So yeah, please log into Delta Math. There should be an activity waiting for you. That's all. Thanks, guys.